one wasn't supposed to be a hard question, but there were a lot of you struggling on that yesterday. So I want to kind of go back over it and make sure we know what's going on. So you're told to use transformations. And we did this back before we had all of our asymptote rules, when we were just talking about what a basic reciprocal function looks like. Ryan, what if I turn off the light? Would that help them? What is it?
Are you gonna drink though?
Okay. Switch, but I never remember which is which.
You got 3 or 2?
Two. Okay. What does the 1 over x, the reciprocal function, look like?
I got this.
You can always plug in 1 over x, you can't put in 0. 1 over 1 is 1. 1 over 2 is a half. 1 over negative 1 is negative 1, negative 1 half. So the parent function looks something like this. Now we didn't do tons with this, but there will probably be a question on your test where I ask you to do the parent function and transformation. So you should know what your parent function looks like here. And then we have to apply our transformations. There's somebody locked out of the locker room.
Locked out of the locker room?
I think they're trying to get back in.
I just let people out.
Oh, you did?
Yeah.
Would that be the people that emailed me asking me to let them in? They might have already got in then.
It was banging on the door. I just stayed out and pulled it.
Okay. So then our transformations, what does the minus 2 do? Right. So we're at, we had a parent function, the vertical asymptote was at 0 when you move left and right.
What if she just trapped herself out there? I heard the door close.
Yeah, there was nobody, like, they weren't in the locker room. They were quiet between the locker room.
I heard the door close.
Okay, I think, well, I think Brian let them out, let them in when you
Yeah,
got in. You just got locked out. Well, they had emailed me asking to be let in, and then. What just happened?
Well, that was the door that locks.
There was no one there. I assumed
'cause I
that meant
just
they
saw
were
it in the-
outside.
Okay, the plus 3. That moves our whole graph up. When you move up and down, that moves your horizontal asymptote. So we had a horizontal at 0. So it moves up 3. So on the test, I would give you a point for the parent function. I would give you a point for correctly drawing in these asymptotes where they belong. You can't just guesstimate it. We know where they go. And then our final function. So if we move, we didn't put a lot of points on these, but right 2 and up 3. Okay, so right 2 and up 3. And so it would look like that. Then I could ask you domain, range, asymptotes from this. Where is the vertical asymptote? What is the domain?
Negative infinity to 2 union 2 infinity.
Where you have a vertical asymptote, that's the number that gets removed from your domain. Where is the horizontal asymptote?
Y equals 3.
And that asymptote is the number we take out of our range. So our range is the negative infinity to 3 union 3 to infinity. All right, so you'll have one of those on your test. Everybody's okay with how to do that, what the parent function is, how to do your transformations. Okay. I know we struggled with that one a little bit yesterday. Then we had questions just practicing finding the asymptotes. So we'll definitely have that on the test. The first ones, I also asked for the domain. My rule is if it's just one value that x cannot be, then you have to give me the interval. If it's more than 1, I will allow you to list it. So if we look at this, A, you cannot have positive or negative 3 for your x. So the domain is negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. You could have either of those for the domain. Vertical asymptotes are what makes the bottom 0. So x equals 3, x equals negative 3. You have to have the x equals. Degree of the top is 1, degree of the bottom is 2. Anytime the top degree is smaller, you have a horizontal, y equals 0, which means we don't have an oblique. For B, we can't have 2 on the bottom. So our domain is negative infinity to 2, union 2 to infinity, and that means the vertical asymptote is x equals 2. Degree on top is 1 larger, so that's when we have an oblique. Do I need to work that out? How to get the oblique? Okay, y equals x minus 2, or x plus 2. We can work one if we need to. C. So domain, the only thing we can't have is negative 2. So negative 2 to infinity, negative infinity, negative 2, union negative 2 to infinity. Vertical asymptote is x equals negative 2. Horizontal, y equals positive 2 because it's same degree on top and bottom, so you divide leading coefficients. And D, domain is everything except 1. Vertical asymptote is at 1, and this one didn't have horizontal or oblique. So I tried to give you, had 4 problems, which essentially gave you all the possibilities for your horizontal and oblique asymptotes. So if the degree on top is smaller, it's y equals 0. If it's same degree, you divide leading coefficients.
Is it smaller? Is it gonna be more than 1?
Yes. If the top is smaller, it doesn't matter by how much. It's just an automatic y equals 0.
Okay.
We only get oblique when the top is exactly 1 larger. All right. So you'll have some of those. Make sure you review those asymptote rules before your test. Then the next question, which apparently I didn't number on here. Your vertical asymptotes are x equals negative 1 and 1, horizontal y equals 0. Vertical asymptotes x equals negative 2 and x equals 2, horizontal y equals negative 1. Are those okay?
The vertical asymptote A is x, y equals 0.
Yes.
Can we do x equals plus or minus?
Yes. All right, the next ones. I would like to work through maybe a couple of these. I would like to do C for sure because that one had a hole on it. What other one? Pick another that you'd like to work through.
Just C.
Just C.
Yeah.
B. All right. Oh. So. On the test, I will have it broken down like an A, B, C, D type question. So part A, I'm going to say factor the numerator and denominator. So what could you do on the top? That leaves us 2x plus 1. On the bottom, we can't do anything. Okay, part B, I'm going to say find the x and y intercepts. X-intercept, how do we find it?
What makes the top 0?
Okay, so it's when y equals 0, which is essentially just what makes the top 0. So what would that be?
0 and negative half.
How do you find a y-intercept?
Plug 0 in for everything.
It doesn't matter if you use the original or the factored. If I put in 0 for all my x's, I get 0 over negative 1, which is 0. Okay, then I would ask you for the asymptotes. So vertical asymptote. X equals what makes the bottom 0. So what makes x minus 1 equal 0? Alright, then we have to decide horizontal or oblique. What is the degree of the top?
2.
Oh,
And the bottom? So if the top is 1 bigger, that is an oblique. How do we find obliques?
Synthetic.
Long division. Okay. The bottom goes outside, the top goes inside. Then we start dividing. So we do divided by x.
Two X.
Gives us a 2x. Then you multiply, so you take 2x times the x minus 1. So we get 2x squared minus 2x. Then what do we do?
Change it.
Change our signs.
Cancel.
1x plus 2x.
3X.
Then final step, we're back to dividing. So 3x divided by x is 3. So the oblique is y equals 2x plus 3. You don't have to finish the long division. You're just trying to get the equation of a line. All right. So then, after you go through all those things, I would ask you to graph it. Now your graphs, I'm going to be kind of picky. You have found this information, so you better plot it on your graph. So I'll give you a point for taking your intercepts and putting them on your graph. So we hit the x-axis at 0 and -1/2, the y-axis at 0. Then I'll give you a point for plotting your asymptotes on the graph. So we have a vertical at x equals 1. How do we plot an oblique asymptote?
You go to your y-intercept of your oblique and you pick
It's
the
just a line. So y-intercept is 3. So we start there. And then slope is 2, so that's up 2 over 1. Okay. Next. Then you have to draw in the graph. So you use your graphing calculator. I try to always go back to the original when I do this. Make sure you do parentheses around both the top and the bottom.
Someone's there.
So make sure also this exists on both sides of the asymptote, of the vertical asymptote, so we need the entire thing. So we have 2x squared plus x over x minus 1. Okay, and I can't hardly see that little piece at the top. If you need to, you can always zoom out. We know it has to be there, so then I can see a little bit better. So I have a portion of my graph up here. Make sure when you draw that, it's getting closer to your asymptotes. Down here, we have to go through both of these points. Now, it's not just a horizontal line between them. Those are the two places where you hit the axis, and then you need to be approaching your asymptotes. So that's something that on our last quiz over these, a lot of you lost points because you weren't really drawing your graph getting closer to your asymptotes. It wasn't really a function. You know, I was seeing things like this. It's not, you know, a horseshoe shape or anything like that. It is approaching my asymptotes as it goes on. Is that one okay? So let's look at one that has a hole in it. You probably have one of those.
I think say probably like you're unsure even though you're completely sure that there will be one of the whole one.
Yes, if I'm going to drop any hints, you will have to find an oblique asymptote on your test. You will have to find a hole on your test. You want me to be more
Yeah.
less vague about it? You
Sorry.
will.
There's gonna be a hole in my test.
I know. I'm gonna take the whole punch.
Just start
Just read.
listening.
Just not right in the middle.
Come on. You can study for it.
All right, first step. I would tell you to factor this stuff. For the top, you would have to do slip and slide. So that's x minus 8, x plus 1 divided by 2. So we get x minus 4, 2x plus 1. The bottom, multiply -12 and add to -1 would be minus 4 plus 3. What do we notice?
-4 cancel.
So this simplifies to 2x plus 1 over x plus 3. When something cancels, we have a hole in the graph. value is what makes x minus 4 equal 0.
4.
To get the y value, what do? Plug 4 into what's left. So we get 9 over 7. Alright, when you find that on your test, I expect that full ordered pair. Intercepts, we can base that off the reduced form. So looking at this, x-intercept, that's when y equals 0, or really just when the top is 0, so that would be. Y-intercept is when you plug in 0 for all of your x's, you get 1/3. Vertical asymptote, x equals, what makes the bottom 0? Again, we're looking at our reduced one, just -3. Horizontal or oblique, what's the degree on top? You can base it off the original or the reduced. The degree of the original was 2 on top and 2 on the bottom, so that's the same. So then, if it's same degree, you divide leading coefficients. So 2 over 1 is 2. Okay. So, x-intercept at -1. We get our y-axis at 1/3. Vertical asymptote -3. Horizontal at 2. And then what do we do for the whole? Circle at +4, 9 over 7.
1.2 something.
Point something. Okay. So then you go to your calculator. Again, it doesn't matter if you put in the original or not, so I'll just go with this. So we had 2x squared minus 7x, what was it? Minus 4 over x squared minus x minus 12. And we get a graph like this. Your calculator will not show you the whole because it automatically reduces before it graphs, so you have to be able to find that part on your own. So we look at this. You need to make sure you're drawing it approaching your asymptotes as time goes on. And here we have to go through the intercepts we found. Go through the hole here without filling it in. So it looks something like that. You alright?
Almost. That hurt. I did have a question.
Yes. Huh? Alright, do we need to do any others on this page? Do you want me to show you A and B to make sure you got them? Feel confident? Alright, next page. E and F, do you want me to work out either of those?
Nope.
Alright. So we've talked about the parent function one. We've talked about the asymptote rules. We've done a couple graphing ones. So then, equations and inequalities. So let's try, we'll probably work through a couple of these. So A is no solution, B -1, C is -2. Any of those to start with that you'd like for me to work out? B, B. Okay. honestly, the biggest issue I'm seeing on these problems is not that you don't know how to do them, it's that you're skipping steps, like not writing things out and then dropping negatives, which dramatically changes your entire problem. That's a pretty common issue for everybody. First thing we always did was factor. So x squared minus 36 factors into x plus 6, x minus 6. If I asked you, I know we had one on our last quiz like this, and I just gave you a problem and said, what's the domain? What can x not be in this problem?
Six.
Plus minus.
Okay. So I know at the end I cannot have either of those for an answer. Then if it's an equation, so if you have an equal to, our strategy is to try to get rid of all the fractions, and we do that by multiplying by the denominators. So if I want to cancel this, I take it times x plus 6, x minus 6. And you have to take everything times the same stuff. So everything gets x plus 6, x minus 6. If we do that, those all cancel. These cancel and these cancel. So all of my fractions are 1. So I have 2 plus 1 times my x plus 6 equals negative 1 times my x minus 6. So if we multiply out, negative x plus 8 equals negative x plus 6. So if I add over my x, subtract my 8, and we get negative 1. And we said at the beginning it couldn't be positive or negative 6, so negative 1 is an okay answer. Either of the other two you would like for me to work out?
Which is the answer to C was?
Negative 2. You got actually 0 and negative 2, but the original domain could not be 0. D, you should get negative 16 and 4. E is the interval negative 4/7 to negative 1/2 with parentheses. F, negative infinity to negative 5 with parentheses, union bracket 1/3 to infinity. G, parenthesis 1 comma 4 with bracket. And H, negative infinity to negative 3/2 with parentheses, union bracket negative 1/2 to infinity. What do you want me to work out on that page? Okay, so with equations, we just try to get rid of them by multiplying. With inequalities, we're going to have to keep it, but we have to do what? What's our strategy?
0.
Get 0 on one side and a fraction on the other. So first thing I'm going to do is bring over my 4. It's like a 4/1. If you want to add or subtract fractions, they have to have the same denominator. So this one has 2x plus 1. This one needs it. So I'm going to multiply by 2x plus 1. Huh?
Plus 4. On the top.
Oh. Right.
That's what it's gonna turn to.
Okay, I thought you were telling me I
My
copied
bad.
the problem down wrong.
Nope.
Kept looking at it trying to find it. Okay. So we get x over 2x plus 1 minus, we distribute, that's 8x plus 4 over 2x plus 1. Alright, this is the step where everybody makes a mistake here. What do I need to do with this negative? So then when I put these together, x and negative 8x is negative 7x minus 4 over 2x plus 2. Alright, so now I have a single fraction. What do we do? So we get negative 4/7. And negative 1/2. Alright, so So we made our little number line. Which one is smaller? So when we graph this, we are graphing that right there. So negative 7x minus 4 divided by 2x plus 1. Alright. Before the negative 4 sevenths, my graph was below the axis, so that is
Negative.
between.
Positive.
We went positive, and then after it was negative. We look at our inequality. We say greater than 0, which is positive.
Negative 4 sevenths.
There is no equal to, so everything gets erased.
Do D. I don't know what I did.
Yes, absolutely. Alright,
I got the opposite sign as what it was supposed to
Okay.
be, and I don't know how
is this one okay with everybody? Alright. This problem actually, I know a lot of people were making mistakes on it yesterday. First thing, are these denominators the same? No, so we can't put them together yet. Second issue I saw, when you went to multiply, some people weren't multiplying the negative 1 by things. So whatever you do to one term, you do to all of them. So to get rid of this denominator, we have to multiply by x plus 8. Everything gets x plus 8. What can x not equal in this problem? So at this point, that's gone, but we still have a fraction. So we now need to multiply everything by x minus 8. Those are gone. So we're left with 6 times the x minus 8 plus 6 times the x plus 8 and negative 1 times both of them. So if we distribute 6x minus 48 plus 6x plus 48. Alright, can I FOIL and distribute a negative at the same time? So if I FOIL that, you get x squared minus 8x and plus 8x cancel, minus 64. So that's a negative x squared.
I forgot to bring over my negative.
That would do it. So quadratics, we put everything on one side. Negative 48 and positive 48 cancel. If I add over my x squared, 6x plus 6x is 12x. Bring over my 64. So multiply to negative 64 and add to positive 12.
Positive 16.
So it goes to 0 and we get negative 16, positive 4. Are both of those answers okay?
Yeah.
So it works. What else? Do we need to do another one of the inequalities?
I think we're done. I think we're good.
You guys are okay with like, on G, you know why the 4 has a bracket but the 1 does not? Bottom of the fraction cannot be 0.